Welcome to the first mathematics lesson here on the GW13 Empire YouTube channel. I'm your teacher for today, Miss Leung, and before we go into the lesson, please remember to like, share, and subscribe. Alright, so I'll be starting the lesson on differential equation, particularly first order differential equations. Now, first order differential equations must be written in the form dy dx plus py, which is equal to q. Now, it is first order because the highest power of the derivative in the equation is of 1. Now, whenever we're writing equations or we're asked to find either the general solution or the particular solution of an equation, differential equation, we have to ensure that we first make our equation be of this form. So that's step 1. Rewrite your equation in this form and identify your values of p and q. Now, our second step is to find our integrating factor. And the integrating factor is calculated using the formula e to the integral of p dx. Now, after we find our integrating factor, we can write our general solution. Now, the general solution will be calculated using the formula y times the integrating factor, I'll just write it back here, which is equal to the integral of q times the integrating factor. Now, when we're writing our general solution must be in y. So that means whatever we get, we have to ensure that y is the subject of our formula. Alright? Good job. Now, let us try an example. Alright, good job. Now, the first example that we're going to find the general solution of the differential equation dy, and this is as easy as we can get, dy dx plus y equals to x. Alright, good. Now, first thing, we need to look to see if it is in the form dy dx plus py equals q and identify our values of p and q respectively. Now, the coefficient of dy dx here is 1, so that means it's already, this part is fine. Py would be here. That means p would be equal to 1 and the q will be over the equal sign, and that would be equal to x. Now, after we identify our p and our q, we're going to find our integrating factor. And our integrating factor is e to the integral of p dx. That means whatever p is, we're going to be integrating it with respect to x. Now, that is going to be e to the integral p that we found in this equation is 1, so it's 1 dx. Now, recall from unit 1 that the integral of 1 or any constant is the constant times the value that you're differentiating in respect to. In this case, we're integrating in respect to x, so it's e to the x, and that's our integrating factor. Now, the next step is to write our general solution, and our general solution takes the form of y times the integrating factor. I'm just going to rewrite it, which is equal to the integral of q times the integrating factor. So we're going to now substitute the values that we got from the question and solve. Now, y times the integrating factor, in this case is 2e to the x, is equal to the integral of q, which is x in this time, in this question, times the same integrating factor, which is e to the x. Now we have y e to the x, which is equal to the integral of x e to the x. Now looking at this, we have an integral sign here and we have a function right there that we need to solve. It doesn't end there. We're going to now find the integral of whatever we have after our integration sign or integral sign, and we're going to make y the subject of it. I'll rewrite. So we have y e to the x equals the integral of x e to the x. Now looking at that, we realize right here we have a product, x and e to the x. So we know we need to find the integral of that. But how are we going to find the integral of x e to the x? What do we do? What kind of integration can we do? And so on. You need to note that. Alright, if you said integration by parts, you are correct. Now using integration by parts, we have to identify our u and we have to identify our dv. Because with integration by parts, what it says is that the integral of u dv is equal to uv minus the integral of v du. So u, what would u be? Very good. We'll use e to be our x because we want to reduce it, and or dv we would consider it as e to the x. Now we now have to find our du because from the formula we're missing v and we're also missing du. So we need to find du, and the derivative of x is 1 and the integral of e to the x is e to the x. Now substituting these values back into the formula, we're going to have y times e to the x is equal to the integral of the formula now, u, which is x, times v, which is e to the x, minus the integral of v, which is e to the x, times du, which is 1. Now this is going to be y e to the x equals x e to the x, there's nothing here that changes, minus the integral of e to the x, and remember that integral of e to the x, or the derivative of e to the x, is e to the x. Now from here, again, remember that the general solution is in y, meaning that y should be the subject of the formula. We're going to now divide through by the coefficient of y. In this case, it is e to the x. So dividing through by e to the x. E to the x cancels here, we're left back with y equal. E to the x cancels here, we're left back with x minus 1. Oh, I'm sorry. Remember, whenever we find the integral of a function, we have to add our constant. So we put our constant, and it's going to also be over e to the x. And we can rewrite this. Remember that if we have something in the denominator and want to bring it up, all we need to do is to just bring it up and change the power. So this would be our general solution of the differential equation, dy dx plus y equal x. That's the first one. Alright, suppose they ask us for, given that we must calculate the particular solution then. So the particular solution is basically we calculated the value of c. So I'm going to use a random value now. Let's say 0, 1. Let's see. Yes, we're going to have, no, I want to use 1, 0. Let me use 1, 0. So you know x would be equal to 1 and y would be equal to 0. Substituting these values in the equation, I'll have 0 is equal to 1 minus 1 plus c times e to the 0. So 0 would be equal to 1 minus 1, 0 plus c times 1. So c would be equal to 0 in this case. I did not want that to happen. However, our value of c is 0, so if I plug it back into the formula, the particular solution would be y equals the x minus 1 plus 0 e to the negative x. So you know that would have cancelled, so it would be y equal x minus 1. But this is least expected, or this would necessarily happen. So yes, that's for the first example. Let's do another one.